In this video, we're going to go over example 3, which tells us to find the exact value of a log without using a calculator. Now, you can put all of these in your calculator. You don't know how to put them in your calculator yet, but you could easily Google it and figure out how to enter in these logs into your calculator. And if you want to, go ahead, but it's going to take more time to actually look it up and learn it than just to do this without the calculator. So to be able to do this without the calculator, we will need to rewrite our equations. And then we are going to use what we did last lesson in lesson 3, and then solve exponential equations by getting the same base. Once we get the same base, then we can set our exponents equal to each other. So find the exact value of it without the calculator. So all of these, we're just going to set up an equation. And I'm going to set this equal to x and solve for x. I'm actually just going to go through here and set all of these equal to x real quick. Okay, A through I, all 9 problems. But all of those equal to x. So when you're evaluating, just make an equation, just set it equal to x, and then we can solve. And we can solve by rewriting this in exponential. So this is base to equals. So this is 2 to the x power. And that's going to equal my big number here of 1. Okay, this one just takes a little bit of thinking through. The only way I can get any exponential here to equal 1 is when that exponent equals 0. So in this case, when x equals 0. Now, I kind of made a little bit of a mistake here. I put x equals 0. I made that x, right? This actually isn't an equation. So my answer is actually just 0. So if you put that in your calculator, you would get 0. If you put log base 2 of 1, you get 0. So all of these, I'm going to be solving the equation that I made, but the answer is just the number here. Okay, same thing here. We're going to go base to equals, so 8 to the x power, and that's going to equal my big number of 8. Now this one, you can also think through 8 to what power gives me 8? Well, that's 1, right? But we're going to need this later on, and so the whole goal here is to get these with the same bases, which we do. This is the same as 8 to the x to the first power. So when I cancel out my bases, we do get x equals 1. So my answer is 1. Okay. Same thing here. Base to equals, so 7 to the x power. And that equals my big number of 49. This is another one you can just technically think through, right? 7 to what power gives you 49? And that's 2. And that is because 7 to the x power equals 7 squared. And when I cancel out my common base of 7, we get x equals 2. Okay, so I did all of that to actually, we need that rule right here. I'm going to go base to equals, so 3 to the x power equals 1/9. Okay, I need to get these to become the same base, so I can rewrite 9 as 3 squared. I need to move this up. And so this would be the same as 3 to the negative 2 power. So now the common bases cancel and we get x equals -2. You need to revisit your exponent rules. if you're not sure what happened right there. Okay, this one's very similar. We'll go base to x, so 1/5 to the x power equals 125. One-fifth to the x power, that's the same as 5 to the negative x. And we did that on a lesson or so ago. Right here, when I had 5 to the negative x, I rewrote that as 1/5 to the x. That is a similar rule to this right here. So I know my base needs to be 5, and so 5 to what power gives me 125? Well, I know 5 squared is 25, so if I go 5 cubed, that is 125. So cancel those, we get negative x equals 3. And so therefore, x equals negative 3. So if you were to put this in your calculator, you would get negative 3. With this one, we have to know that that's the common log, and the common log has a known base of 10. So this is 10 to the x power equals the square root of 10. They almost have the same base. I can rewrite this one with a rational exponent. This is the same as 10 to the x power equals 10 to the 1/2 power. Because there is a known 2 here and a known exponent here of 1. So whatever your exponent is your numerator, and then whatever is the index comes around and becomes your denominator. So now those cancel, and x equals 1/2. Same concept here. This is a common log, so that's a base of 10. So we've got 10 to the x power equals our big number. Kind of a bad arrow. Let me rewrite that arrow. Looks like I'm just pointing to the index, and I want the whole thing. So the cubic root of 100. I need to get these to be the same base. So this is 10 to the x power. I can rewrite 100 as 10 squared. So therefore, I can rewrite this here as 10 to the 2/3 power. Same concept as this. Whatever is the exponent is your numerator, and the index comes around and becomes your numerator or your denominator. My bases cancel. And so x equals 2/3. Now we have a natural log, and the natural log has a known base of e. So base to equals gives me e to the x power, and that equals the square root of e. So e has an exponent of 1, and there's a known index of 2. So that 2 is going to come around and become the denominator. So this is e to the x equals e to the 1/2. My bases cancel, and we get e equals 1/2, or x equals 1/2, I'm sorry. Okay, and then lastly, this is the natural log of base e. So we have e to the x equals e cubed, e's cancel, and x equals 3. So my answer is 3. So when we are wanting to get the exact value without using your calculator, you need to put these into exponentials and then get the same base so you can cancel out your bases and set your exponents equal to each other.